All right, what up, fam? This is our first AP Stats quiz review. Let's hop right into it. I'm going to read the questions out loud just in case you want to hear it. If you don't, you might want to fast forward a little bit. Here we go. A particularly common question in the study of wildlife behavior involves observing confrontations between residents of particular area and quote unquote intruders. In each contest, the residents either win or lose the encounter, assuming there are no ties. Observers might record several variables listed below. Which one of these variables is categorical? So the main idea here is this word categorical, and the other type you could think about is versus quantitative. The main thing you want to know about these questions here is that there is the quantitative effectively means that it takes on a number of some kind. However, be very, very careful because there are some categorical numbers. The only categorical numbers that you might be aware of are things like social security numbers or phone numbers, where the number actually isn't in a specific order. The quantitative ones, though, are numbers that are in order. So first of all, the letters B, the letters D, and the letters E all say the word number. So we kind of know right away the number of animals. Okay, that's definitely a quantitative variable, takes on a number. The total number of contests, definitely again. The number of residents, okay, fine. All of these guys are definitely quantitative. So now it's going to be between one of these. In some sense, letter C should be somewhat obvious. You're in a category, you either win or you lose. However, the word number doesn't show up here. However, it does say in seconds. So you know that seconds could be 1 or 2 or 3 or 4, so on and so forth. And I don't know if you've ever seen those videos. Some of these confrontations can be quite long between these animals. So definitely not just a category of a few seconds. It's going to be quite a few different values that you can take on. So that's not going to be right either. Correct answer, letter C. Let's move on to number 2. Number 2, you measure the age, years, weight, pounds, and marital status, single, married, divorced, or widowed, of 1,400 women. How many variables did you measure? So one thing I do want to talk about that was confusing quite a few people in class is what this 1,400 women are. These are called the individuals. Individuals. I can spell. All right, individuals. These are not part of the variable. They are who is being studied. So it's in the individuals. In this case, it's actually a specific sample because you're not having every single woman on the planet. You're getting 1,400 of them. They are called individuals. The other things listed here, the age, the weight, and the marital status, all three of these are variables. By the way, if you're thinking about these words up here, the first two are quantitative, and the third one here, marital status, is categorical. Regardless, it's 3. Letter C. Let's move on to another one. Here you go. The bar graph at the right shows the distribution of religious affiliation around the world. Which of the following statements best describes what is wrong with this graph? So, in terms of what's wrong with this graph, just glancing at it right away before even reading these things, it doesn't start at 0. This is a super duper common mistake that graphs can make, and this particular one absolutely does make that mistake. It does not start at 0. So, one of these should say it's not starting at 0. Boom, starting the vertical scale of each one. However, I do think it is worthwhile discussing why all the other ones are incorrect, just so we can have a full understanding of the statistics here. So because it's a bar graph, bars should be touching each other. No, actually, that's for a histogram. That's when you have a non-categorical variable. These are categories, right? When you have a categorical variable with these graphs, you split them up to make them clearly separate. However, when it's a quantitative variable, that you make a histogram, and those are going to be coming up in a future problem, so you don't have to worry about what those are. The other category does not need to be subdivided into all the religions included. That is mostly going to be a waste of time, and in fact, in terms of percentages, I bet you each one of these is, it only goes up to looks like 6 maybe, so there's probably going to be a really small number, like a 1 1 1 1. Definitely does not need to be the case. Bars should be in decreasing order of size. Absolutely not. They can be in any order whatsoever. Usually it's simply in the order they show up in the survey. So if this is like multiple choice questions on the test, it might be like A, B, C, D, E, and you don't want to move them around. You would keep them in alphabetical order. We already said letter D is correct. Letter E, the vertical scale should be in numbers of people, not percentages. That is nonsense. In fact, this is definitely not true when you have a very, very large percentage of, or not very large percent, very high number. So in general, your vertical scale can have numbers when it's small numbers, stuff like probably lower than 20 or 30. And you should switch over to percentages, which is called a relative frequency graph as opposed to a frequency bar graph. We do want the relative in this case. The relative is much more appropriate for this situation. Let's move on to our next page. Here we go. We have exactly the same two-way table in both cases here. So here we go. Below is a two-way table summarizing the number of cylinders in selected car models manufactured in 6 different countries. So the cylinders in a car are part of the engine that the piston goes up and down in. The more cylinders you have in general, the more umph your car's got. Not always the case, but in general. So here we go. What percentage of all cars listed in the table have 4-cylinder engines? By the way, in car talk might call that a V4 or a V8 for 8, whatever. Anyways, what percentage of all cars have 4-cylinder engines? So 4-cylinder engines, here we go for 4. So we're looking at the total number. So we have 19 as the total number of cars. This right here, we are going to be calling in our separate table at the bottom. This is our marginal distribution, if you want to get ahead of yourself. But out of all cars, so the all cars is 38. Because we're looking for a percentage, we will have to multiply by 100. So we're going to be doing 19 divided by 38, multiplied by 100. I have faith in your ability to use a calculator. This is going to be 50%. However, if you need help with the calculator on this, there is absolutely no shame in asking for help during class, but that is what you're going to be typing into your calculator there. Let's move on to our number 5. Over here below the two-way table summarizing the number of cylinders in selected car models yet again. Which of the following is a marginal distribution? So you might remember if you have ever used Microsoft Word or Google Docs that you can change the margins on your paper. So like when you have a piece of paper here, the margins are like this section over here. Like over these guys right there are the margins. Likewise, the margins on a two-way table are going to be the stuff that is on the outside. So it's typically these numbers over here, and they relate to the stuff that's on the left. So like this 1 relates to France, the 19 relates to the 4 number of cylinders. Please note the 38 is not a marginal part of the distribution. It's the entire thing. So that's the only way that this margins thing doesn't work here. It is only the ones on the side. So now we just literally just need to read through each one of these, figure out which one of these is in fact a marginal distribution. The percentage of all 4 cylinders manufactured in Germany, that's not marginal because that's boom right there. That's a 4-cylinder in Germany. The number of 4-cylinder cars manufactured in Germany, so this is the percentage. This is the number. Neither one of these, it's the same exact thing. Neither one of them are good. Percentage of all cars manufactured in each country. So not going to be the one we are looking for. I'm going to pause really quick, take a drink of water. Okay, I'm back. So got my sip of water. Here we go. So we were talking about how these numbers on the side were correct. I think I gone over A and B, why those are both wrong, because that's both this number here. And now these ones, I actually would have an argument. I don't think letter C is correct, because this is the percentage of all cars manufactured in each country. And the marginal distribution should actually really be the totals. The answer key does say that this is the correct answer, but the answer I think is correct is the actual number of cylinders, the 4, 5, 6, and 8 over here, or that you could just say that it's not the correct answer. So in this one, I would actually argue that either one of these is fine. Answer key in the back says it's letter C. I vote that it's letter E, and definitely this is Germany only, so that's not going to be what we want. Either way, back of the book says C. I say E, so I'm just going to say C or E, and I will accept either answer. If a question like this shows up on the actual quiz, I will be lenient in the explanation. Maybe you want to argue with me why E is definitely wrong. Like they're definitely saying up here, and I wrote that the margins are on the right-hand side and not at the top. But whatever. I'm moving on to the next question. Let's do it. So here we go. Question number 6. So question number 6, our first talking about the distribution. This one's super duper important throughout the year. You're gonna have to do this so many times. Here we go. Mr. Lee has just collected his last batch of 24 English essays. That's going to be important. All of them as computer files. He's curious about how long the papers are, but doesn't want to be fooled by large font sizes. So he uses the word processing software's word count feature. Below is a histogram of the word count for the 24 essays. Boom, there's our histogram I was talking about. See how the bars are touching because we have a quantitative variable that we are plotting in this fashion. Which of the following best describes the distribution of variable numbers in these essays? So first of all, we have two parts of this. We have a skewed and we have a center, and we have these outliers. So a couple different things to think about. First of all, let's talk about the skew. The skew is the opposite of the data clumping. So the skew is in the tail. If I were to draw a little thing kind of on top of this, like so, we can see that the tail is over here. Here's our tail of our graph. So we would call this a right skew because it is on the right. Another way of thinking about this, that it's how it's a right skew. I should have written skew. Did I just move the camera? No, I just smacked it. We're okay. All right, so the right skew moving off to the right because we have that tail. But the other way of thinking about it is that the data is clumped up on the left and the skew is the opposite of that. So the data's on the left, skew on the right, done. Okay, so we have the right skew version of the tail and it's centered at about one of these two. So you have the right-hand side, so it's definitely not going to be B or D or E. Really quickly, they both have one high outlier. This guy right here is going to be called our outlier because it's a single data point. There's only one of them that has all of these words. It appears to be somewhere between 1,050 and 1,100 total. That's our one outlier. We need to figure out where it's centered. So in order to describe the center, you always have a choice. You can either use the mean or the median. You do need to choose carefully. You want to use the mean when it's symmetric. And you want to use the median when it's skewed. So in this particular question, it is a skewed median. So because there is a skewed median, that doesn't make sense. It's a skewed distribution, so you want to use the median, which is what we're going to do. So to find the median, normally what you would do, like way back when, 4th, 5th grade, when you first learned how to do the median, you'd have to write down all 24 of the numbers, whatever these numbers happen to be. Maybe, 625 and 650 both fall, or 630 both fall in this little section. And then maybe like a 675, and you have 4 essays that are all 675, maybe one that's 660. These are all the values in between 650 and 600. Regardless, you'd write all 24 of them up and you kind of cross off the edges to figure it out. To do it for our class, what we're going to do is we're going to say there are 24 essays. Because there are 24 essays, if we were to split this in half, there are 12 on the left and there are going to be 12 on the right. So if there's going to be 12 on the left and 12 on the right, 24 total. The middle value is going to be in between these two. So the median is between the 12th and 13th values. So we need to figure out where is the 12th and 13th values. There are 2 values that show up here because there's that little 2 there. Remember that means there are 2 essays that are between 600 and 650 words. There are going to be 4 essays that are between 650 and 700 words. There are 6 essays between 700 and 750 words, and then there are going to be 5 essays, so on and so forth. I have a feeling that you can count how many of these are in each section. So again, it's how many essays are that many length in words. The median is going to fall in between the 12th and 13th number. So if we were to write these all in a row, there's going to be 2 and then 4 and then 6. Those 3 numbers there add up to 12. So in other words, between the 12th and 13th essay is going to be somewhere in this section between 700 and 800. That's 750. Answer is, in fact, A. Whew. Let's move on to number 7. Number 7, the following histogram represents the distribution of acceptance rates, percent accepted, among 25 business schools. So please note how I'm circling the total number in all these questions. Going to show up. Pretty important that you should probably circle, underline, highlight, whatever is your fancy. Make sure you know that that's what's going on, because otherwise you got to count. How many am I adding up over here? We got 25. All right, moving on over here. What percentage of the schools have an acceptance rate under 20%? So we want to know how many of them are to the left. Most histograms, the rule is it uses the right endpoint. So in other words, this 3 could include the 20. So if it had exactly 20%, it could be in the third. So it does say under 20. So you could argue that there's no answer for this graph, but I'm not going to do that. I'm going to say that there is a 1 here and a 3 here. There are a total of 4 of the schools that have below a 20%. So there are 4 of them. There are 25 total. You got to be 4 divided by 25. Again, multiply by 100. I have faith in your ability to use a calculator. This is going to give us 16%. By the way, you say, oh my gosh, how'd you do that in your head, Mr. Richards? You can do it really fast, actually. Anytime you're dividing by 25, all you actually have to do is take the numerator and multiply it by 4. So 4 times 4 gives you the 16. That's how you can do that fast. So, if you had 20 of these, 20 times 4 would be 80%. 20 over 25 is 80%. You can check it if you want. The reason why is 4 quarters in a dollar, you're multiplying by 4. Anyways, I'm done talking. The answer is letter D. We're moving on to the next question. Boom. After that, question number 8. Here we go. A policeman records the speeds of cars in a certain section of roadway with a radar gun. The histogram shows the speed for 251 cars. I circled it again. The max value is 35. So this one's going to be a 35 mile per hour going. If the value 35 miles per hour was actually 29 miles per hour, so their speed man records the speed. He was off by 6. Got a ticket for no reason. How would the mean and standard deviation change? So big concept here. Might not have talked about it in class. I don't know if I even did, but the idea here is because the total, what you're doing when you're finding out like the mean, like you'd be adding these up. Like maybe this one is, a 20.5 speed, and then you're adding another one that's going 21, you're adding another one that's 23, and you're adding all of these up and then dividing by 251. If you take a number that is on the top and decrease it, make it smaller, then the overall mean would also decrease. You could argue that it barely decreases and therefore it doesn't change, but let's just say the mean decreases. So because the mean decreases, there's only one correct answer, that letter B. But so we could be done if it's actual test or quiz, but let's make sure we understand why the standard deviation decreases. A standard deviation is talking about how far away from the center you are. The center of this graph does appear to be about 28, maybe 29, and it's really symmetrical. It's really be finding the mean. So the standard deviation is how far away from the center you are. If the 35 here was taken away, now the average distance between the center and the other values would also decrease. So in this case, it's going to be a decrease. Please note, just because a value decreases does not mean that the standard deviation decreases. If, for instance, that this one of these 25s was actually like a 19, it was all the way over here, now the mean would decrease, but the standard deviation would actually increase because you have a value that is further from the center. You're asking about, in terms of deviations, you're asking how far away are you from the middle. This one went closer to the center, and therefore the standard deviation decreased. Let's move on to number 9. A set of data has a mean that is much larger than the median. We gave an example of this in class. We said that the United States incomes are an example of a mean that is much larger than the median because there are a couple of people who make a bunch of money, they make millions and millions of dollars, whereas most people are making under $100,000. Because of that, that is going to be a skewed right distribution. The data is clumped up on the left, and we would say it is definitely skewed to the right. And that is going to be true for all of these. You could know the distribution is not symmetric. In general, symmetric distributions will have the same mean and median. And anytime you have a distribution that's skewed to the left, it would be the other way around, where the mean is smaller than the median. We have no information of whether it's bimodal. We don't know. And the few low outliers, we were just talking about how this one has a mean larger than the median. Our example, the people making a bunch of money, they have a few big outliers. So again, the low outliers would actually go with that letter B. Those two would be connected to each other. Let's move on. Number 10. So according to the Bureau of Labor Statistics, the monthly percentage change in the number of jobs over certain states was a unimodal with a mean of 0.08 and a standard deviation of 1.7. So again, what that's kind of saying is that you have a center here of 0.08, and your average deviation from the center, or the standard deviation, is around 1.7. So in other words, you're going 1.7 away. In other words, it's going to be 1.78. And if you're going 1.7 in the other direction, by the way, that would be like negative 1.7, right? So 1.70. So what would that be? Negative 1.62. Someone can like double check my math. But you're basically going in outwards directions, and you actually continue going. So you continue going, that would be 1 standard deviation away. If I were to do 2 standard deviations away, this would be 3.48. I hope I'm adding 1.7 correctly. And then you're again going another 1.7, going in both directions. It's effectively what's saying this is how spread out the data is. Most data is going to fall into here. And then if I were to subtract it again, oh my gosh, to negative 3 point, man, I'm going to cheat and use a calculator. What is negative 1.62 minus 1.7? I am cut from the team, 3.32. I should be able to do that. Yeah, anyways. So we have that. So most of the data is going to fall between here. Another data is going to fall between here. If it happens to be normally distributed, which it may or may not be, we have no idea, then we would say that 68%, 95% rule we were talking about. We don't know that though. Anyways, we're done talking about the idea behind the question. Now let's actually read the answers. Letter A, the largest monthly change was 1.78. Well, that's nonsense. I just showed that some of them are going to be, 3.48 or higher. So that's nonsense. The distribution of monthly changes is strongly skewed to the right. We have absolutely no idea if it's skewed to the right. It could be, like I said, normal, where it's symmetric on both sides. It could be strongly skewed to the right. It could be skewed to the left. Maybe there's somebody that the percentage change of jobs, maybe one state had a factory close and their jobs are negative 5%. They're like all the way over here. So it could be skewed to the left instead. We have literally no idea. Letter C, the most monthly changes were negative. Again, we actually don't know. It's possible that the mean was dragged up by a huge positive value and there were mostly negative values. However, in some sense, it's in the event that it was a perfectly symmetric, we actually know it's the other way around, that the changes were positive because we have a positive center. So 50% would be above this 0.08 and 50% would be below the 0.08. So things like 0.07 would still be a positive. So most would be positive if it was symmetric. But again, we don't actually know one way or the other. Letter C, the magnitude of monthly deviations from the mean was typically about 1.7. That's literally exactly what the definition of standard deviation is. That's letter D. We're done with the question. A mistake has been made. It makes no sense for any deviation to be greater than the mean. This is all absolutely nonsense. Makes no thinking about it whatsoever. The standard deviation can be anything by comparison to the mean. In fact, the main one that we drew on the board has a mean of 0 and a standard deviation of positive 1. That's our normal deviation. So that's like a huge idea. Definitely nonsense. Letter D is correct. Let's move on to our next page. Now, here's a stem and leaf plot. I actually did not go over these in class. I remember specifically skipping that slide because I was being lazy. And now that I'm reminded I need to teach that in class like tomorrow, here we go. Rainwater was collected in water collectors at 30 different sites near, notice I again circle that 30. That's the total number. You really got to get in that habit of looking at that number. It's going to be useful. 30 different sites near an industrial complex, and the amount of acidity pH was measured. The data range from 2.6 to 6.3. Which of the following stem plot of data was constructed, where it says 3, 7 represents 3.7. So for instance, we have 2.6, 2.7, 2.9, 3.2, so on and so forth. Which of the following box plots is the correct representation of the same distribution? So remember, anytime you're doing a box plot in general, no matter what they're going to look like, man, that was atrocious. I mean, that is next level bad. Either way, this is going to be your minimum value. This is going to be your Q1. This is going to be your median value. Here's going to be your Q3, and here's going to be your max. So like right away on this question, we can look and say the data range from 2.6 to 6.3. The lowest is 2.6. The highest is 6.3. We know the minimum's got to be a 2.6. So that one's got a 2.6 minimum. That's got a 2.6. That's got a 2.6. D is nonsense. That one's got a 2.6. And it also has a 6.3 maximum. That's 6.3. That's 6.3. That's 6.3. That's 6.0. We already marked that one wrong. That's 6.3. Okay, those are the only ones we can cross off. So we are going to have to figure out what is the median, what is the Q1, what is the Q3. just like we did in that previous question, because we have 30, that means that we have 15 values on the left and we have 15 values on the right. Because of that, the median value is going to fall between the 15th and 16th values. So this one's 2.6, the first value, the second value, the third value, the fourth value, the fifth value, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's our 15th value. In between 4 and 5 is 6, so the median is definitely going to be 4.5. We calculated that by doing 4.4 plus 4.6 divided by 2. And again, it's between the 15th and 16th values because there's an even number. When there's an odd number of data points, you instead are just going to find the median by itself. So either way, there's that 4.5. So we got to figure out any of these not at 4.5 for the median. Okay, letter E is nonsense. We can skip that guy. Let's go back up to here. So we found our median. Now Q1 is the median of the first 15 values. So now we do have an odd number. Because we have an odd number, we can go ahead and figure out what is that very middle value. When I was helping another student with this, it was actually helpful just to write out this for one time. 1, 2, 3, 4, 5, 6. I'm going to be really obvious 7 there. And I'm going to write 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this is a little bit obnoxious to do it. But the concept is that I have clearly 6 numbers over here, and I have also 6 numbers over here. 1, 2, 3, 4, 5, 6. Well, maybe I have 8 numbers. What the heck? What am I saying? I really counted wrong. This is unbelievable, Mr. Richards. There are 7 numbers over here and 7 numbers over there. What a disaster. I'm going to redraw this. I'm going to redo it. I'm going to pick another color. Mr. Richards made a mistake. Sad times. 1, 2, 3, 4, 5, 6, 7, 8 in the center. That's what I was hoping for. And then we have 9, 10, 11, 12, 13, 14, 15. Woof. Okay, the point is we have 7 numbers here. We have 7 numbers here. So the middle is the 8th number. So we're going to have to figure out what is the 8th number. So because we're figuring out what is that 8th number, here we go. The first number, the second number, the third number, 4th, 5th, 6th, 7th, 8th number. The 8th number is 3.8. Likewise, from the other side, you're going to do exactly the same thing because you're finding the middle of the middle. So you found the middle of the first 15 numbers. You also need to find the middle of the last 15 numbers. So again, it's going to be 8 away from that 15. So because it's going to be that 8 away, 8 away from the 15, we need to figure out 8 away from there. So we have 1, 2, 3, 4, 5, 6, 7, 8 appears to be 5.6. And then we just got to figure out which one of these does that. So 3.8, now it's like 3.4. So that one's definitely wrong. This one, that appears to be 3.8, and that appears to be 5.6. It looks like B is the correct answer. Yeah, definitely going to be the correct answer there. Boom, we're all done. Recap really quick. Stem and leaf plots, 2.6, 2.7, 2.8, or 2.9, sorry, there's no 2.8. And that's how you read them, just like it says with this key. When you found the median, you had 30 values. Because you knew you had 30 values, you're going to have 15 on the left, 15 on the right, and therefore your median value is going to be the average of the 15th and 16th values. You're adding 15th and 16th value. When you counted this, it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it was in between 4 and 6. In between 4 and 6 is 5. That's where I got that 4.5. That's our median. After we did that, we had to figure out what is the middle of the middles. That is what Q1 and Q3 are. We're finding the median again. So halfway between 15 is 8. Halfway, so we counted the first 8 numbers and we ended up at 3.8. And then we counted from the other side. We counted 8 numbers over and we got the 5.6. Whew. All right, moving on to the next question, number 12. Here we go. Mr. Cottrell asked the 26 seniors in a statistics class. How many AP courses they had taken during high school? Below is a box dot plot summarizing the results of his survey. Mr. Richards is over here with a 9. All right, what is the interquartile range for the number of AP courses? So interquartile range in class, I have been calling this the IQR. The IQR is by definition Q3 minus Q1. It is a single number. Because it's a single number, we're going to cross off A and B and C. All three of those are nonsense. They are not a single number. The interquartile range is a single number. But just like the previous question, we need to figure out what is the middle and what's the middle of the middle. So we're dividing that in half. So we're going to do 26 and it's split into 13 and 13. Halfway for 13, there are 6 values to the left, 6 values to the right, and the last value smack dab in the center of the 6, and 6 would be the 7th number. So we're going to be looking for the 7th number from the left and the 7th number from the right. What it means by that is we have a 1, 2, 3, 4, 5, 6, 7. This is our 7th value down there at number 3. So that means that our Q1 equals 3. We need to figure out what our Q3 is. And now we're going to go the 7th number from the right. So 1, 2, 3, 4, 5, 6, 7. Right there. Boom. That is our Q3. So our Q3 is going to be 5, that number on the bottom. And if we were to do 5 minus 3 to get 2, and honestly, this is a super mean question. I'm kind of upset with the AP book for this one. This is another question where if you did write letter C, I'd actually give you credit for it because it is 3 to 5 quite clearly, but they are trying to trick you. The answer is D, 2, just a single value of what we are looking for. Let's move on to number 13. So the 5-number summary for scores on a statistics exam. By the way, the 5-number summary is exactly the same thing as saying a minimum, a Q1, a median, a Q3, and a maximum. As a reminder for this particular question that's going to be useful, we talked about it briefly on any box plot whatsoever, but on any box plot whatsoever, these are all 25%. No matter what the box plot is, every single section that you're drawing between the line, by definition, you are finding 25% for every section. So likewise, if I were to do between, in this box is 50%. If you were to include this side to this end of this box, that's 75%. But within every little section is 25%. So likewise, in these questions, between each one of these is going to be 25% of the values. In this particular question, they're asking how many students fall between 35 and 61. Because these are right here, yet again, 25% of the values. Because we have 25% of the values, none of these looks to be the answer at first glance, but it says about how many students had scores between, look at this, I didn't circle my 380 like I should have. That's how many we have in class. So we need 25% of 380. So 25% of 380. Now, all of us are supposed to know how to do percentages, but if you don't, here's your quick little lesson. You always have the percent times the of equals the is. When you write percentages, remember it always means the decimals moved over twice. So 25% is 0.25. You might have remembered it from earlier years as 25 over 100 in your calculator. I don't care how you remember it. Doesn't really matter to me. The point is the answer to this question is 0.25 multiplied by 380, and you're going to get an answer. You could also think about it in a slightly easier way, just kind of like the same idea as I was talking about before. 25% is like a quarter, 1/4. 1/4 of 380 is in fact 95. Or you could have just typed into your calculator 0.25 times 380. I have faith in your ability to use a calculator. I am not going to go over that part of it here. Whew. Let's move on to our last couple questions. The most important questions on the test. When I say the most important questions on the actual AP exam, you will have 40 multiple choice questions and you will have 6 free response questions. And of those 6 free response questions, 5 of them are regular free response questions, and one of them is kind of like a bonus that we'll talk about later in the year. But the main idea is that for every one free response question, there are 8 multiple choice questions, and that's how my tests are going to be. And they're going to be worth exactly the same, just like on the AP test. So in other words, your quiz is going to have 8 multiple choice questions, That's half. And then it's going to have one free response. That's half. So you got to get this free response question right. And I'm telling you right now, what the free response question is going to ask is exactly this situation. It's going to ask you to describe the distribution in some way, shape, or form. I think I also have you make a histogram. I don't remember. I have to look at it one more time. But it's super important. You got to know how to describe the distribution. And when you describe the distribution, you need to have a sentence for the center. You need to have a sentence for the spread. And you need to have a sentence for the shape. You need all three of these to get your E on the exam. Center, spread, and shape. Let's do all three of them. First of all, we typically actually want to start with the one at the bottom, the shape. The reason why, I will re-explain in a second, but you usually want to start with the shape. This one is, just like a previous question, right skewed, because the data is clumped up on the left, the tail is on the right. If I were to draw a little thing over the top of it, it would definitely be right skewed. How would we write this answer? They gave us this number of electoral votes. So to answer our shape question, the distribution of number of electoral votes is, and you always want to start by saying something like that. You're describing the distribution, so start by talking about the distribution. The distribution of, what is it a distribution of? It is a distribution of the number of electoral votes. So you're looking directly at the graph. Please note, you could have also looked at the sentence, shows the distribution of electoral votes, and you could have added some more bonus stuff. The distribution of number of electoral votes for the 50 United States and the District of Columbia based on the 2010 census is, and going on from there, but this is enough. The distribution of the electoral votes is, and we just said right skewed, and you also should mention the idea of how many peaks it has. This has one peak at the top, so we call that a unimodal. It's right skewed and unimodal. After you've talked about the center spread shape, after you talked about the shape, you want to talk about the center. For the center, we wrote it earlier. When you're talking about the center, you have a choice, mean or median. Anytime you have a mean, you're using it for symmetric distributions, and the median goes with skewed distributions. So you need to find the median. The center of this distribution is the median, which is, and you could say about or between, well, we'll talk about it in a second. We're going to start writing what I'm saying there. So now we have to find the median. So to find the median, oh my gosh, I forgot to circle 50, but it's not really 50. It's actually 51 because it's 50 United States and the District of Columbia. So we actually have 51 total here. We need to find the median. The median for 51 is always going to be, remember, there's going to be 25 on each side because there's 51 and that one in the center. It's going to be the 26th value. So we need to figure out what the 26th value is in our list here. So this is all the values between 0 and 5. There are 13 such values. By the way, this is probably the 13 states that have only 3 electoral votes, up to 5 electoral votes. We're talking about states like Wyoming and Nebraska that just don't have that many people. They're all going to have a 3 electoral votes, and the ones that have a lot of electoral votes are the ones that have a lot of people. So this is going to be California and Texas, and I think we have like New York and Florida, maybe Ohio, stuff like that. We'll have like 23, 24 electoral votes, and it was updated in 2020, so these are actually not even accurate anymore. Either way, point is you have 13 states between 0 and 5 electoral votes, and you will also have a total of 17 states between the 5 and 10 electoral votes. Please note, usually the 5 is going to be included over here on the left, and the 6 in the to 10. This is like really 6 to 10, and this is 0 to 5. So there's 17 of those states. Because you're looking for the 26th state on the list, the first 13 are between 0 and 5, but the next 17 are going to be between 5 and 10. So we know for a fact that the median is somewhere between 5 and 10, and more specifically between 6 and 10 for this particular distribution. We're not certain exactly where because it doesn't say like how many in between. Like you could be more specific as to how many states actually fall between here. But because you can't do that, all we would say is, and the median is between 6 and 10 electoral votes. Note how I use that word again, the context. They really want that. So the center of this, see if you can't read my handwriting, the center of this distribution is the median, which is between 6 and 10 electoral votes. Whoof. All right, so we have a sentence on our shape. We have the sentence on our center. Now we need to talk about the spread. Anytime you've already used the median, you might as well use the IQR. When you're talking about means, by the way, you want to use standard deviation. So that could be a cute little note for yourself. Maybe a little chart. So if we have some, I'm going to do this in like another color for like little notes. Let's do pink. So let's say we had a symmetric. If you have a symmetric distribution, we already talked about want to use the mean, and you're going to want to use the standard deviation. Standard deviation. Whereas if you have a skewed distribution, you're going to want to be using the man, I can't even remember what I'm saying, the median and the IQR. You can also use the range for both of these. Range is appropriate for either one. If you want to, for your spread. And actually, I would just mention it in both of them. You also want to make sure that when you're talking about the spread that you include outliers. So, yeah. Okay, so again, mean, median, center, the spread, use the standard deviation or the IQR. You can always include the range and should also include outliers. Okay, so this one right here, the next sentence, we're going to be talking about the spread. For the spread of this shape, like I said, we need to figure out what the IQR is. But in order to figure out what the IQR is, we got to find the middle of the middle. So the middle of the middle, 26 divided by 2. So the 26 date, remember we have 25 now on each side. So between the 26th and the 1st, the 26th and the 51st. So between the 13th and 14th numbers on both sides. So the 13th and 14th numbers appears to be about 5. So we kind of know that for this problem that Q1 is going to be 5. For Q3, we need to figure out from the other end where approximately the, man, I can't speak, where approximately the 13th and 14th from the end is. So here is 1 state, 1 state, 2 states, 2 states. This is 4 states. Have we gotten to 13 yet? 1 plus 1, that's 2, 4, 5, 6, 7, and 4 more is 11. So we're looking for the 13th. Definitely going to fall in between here because there's 11 in this little section. So our Q3 is somewhere, like I said, it's about 5. Our Q3 is somewhere between 10 and 15. So like somewhere between 10 and 15, you can just make up a number, somewhere around there. So the IQR is somewhere between 5 and 10. So we could say the spread of the distribution of electoral votes can be described by the IQR, which is about, what do we say? Somewhere in the realm of, it's either between 5 and 10. So is about, I should have said between, is between 5 and 10. And again, the reason why is because this is somewhere in between 10 and 15. This one definitely actually is 5. So 10 minus 5 is 5. 15 minus 5 is 10. That's where I got the 10 and 15 from. Where I got the 5 and 10 from, sorry. So again, the IQR is going to be somewhere between 5 and 10. You should also talk about the range and any outliers. The range appears to be from 0 to 60. Please note, if you actually knew the facts for this situation, that it's actually from 3 to I think 59, but we don't know exactly what that is, so we're going to assume it's possibly 0. So the range appears for it to be from 0 to 60 with 2 outliers. And that's it. I think we're good. I think we're done with that question. We have all our center spread and shape. We accurately described it, and we're done. Let's move on to our very last question. This one, I don't think I made this question on the test of making histogram, but I might have, and it's a good practice to do anyways, just to make sure you're getting points. In the event that it shows up on the AP exam, you need to make sure that you're getting your points. So want to construct, let's read this question. So each student in Mr. Quigsley's class was asked to shoot 20 basketball foul shots from the free throw line. The data on the number of successful shots for each student is given here. Please note, on these numbers, you weren't told how many there are, but you can count 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 30 data points that we're going to need to enter here. So it says construct a histogram for the distribution, choose an appropriate bin width, and be sure to provide a label and scale for each axis. So let's go ahead and do this. These are going to be some free throw shots. Free throw, maybe number of free throw successes. And over here, I can just say it's the frequency. Please note, if you had a whole bunch of data points, like I was saying before, if you have like fewer than 20 or 30, frequency is typically going to be your best bet. This has exactly 30, and there's going to be less than 30 points up here. So frequency is good. If you had way more than that, you want to do relative frequency, but we're going to do regular old frequency for this one. And now we need to use some tick marks up here. We're going to do the bin width first. You always do bin width first. So the bin width, what the bin width is, because we have 20 basketball shots, we're going to make sure that we have a number that is divisible by 20 to make sure that we have a nice, neat, even situation. It doesn't have to necessarily be, if you were asked to shoot 19 free throw shots, then 19 is not divisible by anything. So you probably still want to choose one. In general, you want to be able to have somewhere in the ballpark. Let's look at the previous question, what they did. So how many bars would you had? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had like 12 sections. You kind of want somewhere in the ballpark of like 5 to 10, 5 to 15 different little sections. And because we're going up to 20, like 20 is definitely going to be our far right hand side of the graph, and 1 is going to be all the way on the left. To get to 10 sections, our bin width should be 2, 4, 6, 8. So 2, 4, 6, 8, 10, 12, 14. Oh gosh, I didn't do a good division. 16, and that's magically an 18 now, and a 20 over here. Had to extend it a little bit. So we have 2, 4, 6, 8. The idea is our histogram is going to have each one of these as a bin width. Now we need to figure out for each one of these how high is our section going to be. I've already done this question once, so I knew in advance that the highest bin width happens to be 7, but you could have figured that out by figuring out how many are between like 8 and 10, how many are between 10 and 12, because it looks like there's a lot of 11 and 12s. So you can just count how many are between like 11 and 12, and you have 1, 2, 3, 4, 5, 6, 7, right? So 7. Either way, we can just go by ones. 1, 2, 3, 4, 5, 6, 7. By the way, in the actual AP test, you do not need to label all the tick marks. You only need to label one tick mark. So if you label 1 here and then you're done, you're good to go. But I kind of like to label at least 2 or 3 of them just to make sure you're consistent across the entire thing. Like just a 2 might not be enough if you haven't clearly labeled this as 0. So maybe like 2 and 4, and then you're good to go. All right. So finishing this off, now we actually need to make our heights. So between 0 and 2, we need to figure out how many of them are between 0 and 2. Turns out there's just the one that is in between the 0 and 2. So we can go ahead and start filling this in. I'm going to do a different color. I'm going to do green for these. So now we have this guy right there. There it is. If you want to fill yours in, you can. I will not be filling mine in. Between 2 and 4, so you need to figure out how many of these are... One last thing I forgot to mention. I apologize. It didn't matter for this one because there were no 2s, but in general, the right-hand side number is included in the total. So in other words, if I have any 4s, it'll be included to the stuff of the left of it. If I have any 6, it'll be included in the stuff to the left of it, so on and so forth. All right, between 2 and 4, I don't think there were any. Nope. All right, between 4 and 6. So between 4 and 6 really meaning 5 and 6. How many had 5 or 6? There was the 1 here. I don't think there were any other 6s. Doesn't look like it. So we can go ahead and cross that 6 off there because we have our one little height right here going right there. And then from 6 to 8, now we are doing really 7 and 8, right? So we're going to find out how many 7s and 8s there are. So we have 1, 2, 3. I think that's it. So we're going up to 3 on this one. That are between 7 and 8. Now the next one's going to be 9s and 10s. So we're going to have 1, 2, 3, 4, 5, 6. So that one goes all the way up to 6. You can see I am on the struggle bus here. All right, so we have up to 6 there, and mine even looks like it goes up to 5 maybe, so maybe get a little bit higher on that. Yikes. All right, well, wonderful job, Mr. Richards. Let's keep on going. Number 1, 2, 3, 4, 5, 6, 7. There's the 7 I was talking about, so this one goes up to 7. And then now for 12 to 14, remember it's only numbers 13 and 14, so there are 1, 2, 3, 4. So it goes up to 4, which is about right there. Wonderful. For 15 and 16, there's 1, 2. Did I forget 1 on 12? Dude, yikes. Hold on, I'm going to pause really quick, make sure I'm going to recount. All right, so I definitely miscounted. There are 8 of them. Yikes, Mr. Richards. Yet again, there are 8. Someone might have already caught that in the video when they were going over it themselves. But yeah, there are, in fact, 8 of them up there. So it does go up to 8. Sorry about that. That's the second mistake in the video. Yay. All right, should have made red in there. Whatever. All right, so between 15 and 16. Or sorry, crossing them off. Oh my gosh. So 15 and 16. I was supposed to do that first. So where is our 15? 1, 2, 3. We cross this one out too. All right, so we have 3. And now between 16 and 18. Oh yeah, did I miss a 14 as well? Dude, Mr. Richards. All right, between 16 and 18, we only have 1, and we have the 120 as well. All right. Anyways, I apologize. If you want to fill these in, you can. There's our histogram. Beautiful. If you want to talk about some center spread and shape, I'm not going to write the sentences out here, but it could be a good idea to talk about that center spread and shape. So this guy is roughly symmetric with a single outlier on the outside. Because it's roughly symmetric, we can just talk about the mean. The mean appears to be approximately 11, maybe would be the mean number of free throws successful. That is really, really good, by the way. Over 50% for a high school. Pretty decent. After that, we have center spread and shape. So the spread here, you probably want to talk about standard deviation. You actually have to calculate that using a calculator, but if I were just to guesstimate, the standard deviation is probably about 2. So it looks to be about 2 from the center. Anyways, the student who made only 1 successful foul shot actually made 10 successful foul shots. If this change is made, how will the value of the mean and median change? So the mean will definitely increase. So we could say mean increases because the number increased again. So just like before in that previous multiple choice question, the mean increased for sure because total increased. However, the median, where's the median again? So the median, we had our 30 total shots. Because we had our 30 total shots, the median will be between the 15th and 16th values. So we had 1 here, 3 here. It was 6 for this one. It was 8 for this one. And we're trying to find where the 15th value is. So that's 1, 2, 5, 11. So the median is somewhere in the ballpark of 10 to 11. So in other words, the median is already where it was. And it's not going to change because 10 is below the current median. As was the original data points. Of 1, the median is unchanged. I'm going to repeat though, this was great practice, in terms of thinking about stuff, but for the actual quiz, much more likely to have a question where you have to describe the center, spread, and shape accurately. That's it for this video. Have a wonderful rest of your day, guys. Peace.